Now next chapter is chemistry of group 16 elements. In long form of periodic table, there are total 118 elements, and these elements are classified into 4 blocks, that is S block, P block, D block and F block. The elements belonging to S and P block in the periodic table, these are called as representative elements or main group elements, and P block elements belongs to group number 13 to group number 16. Actually, group number 16 elements, these are the P block elements. Now long form of periodic table, it is the arrangement of elements, 118 elements on the basis of atomic number. So according to the modern periodic law, the properties of elements are the periodic function of their atomic numbers, or the elements in the periodic table, these are arranged on the basis of atomic number or electronic configuration. Now in periodic table, there are total 18 groups or columns, and there are 7 rows or periods, and as I said, altogether there are 4 blocks S, P, D and F. Now let us see the names of various elements, number of groups and the total number of rows. Now hydrogen, this is the first element. Its atomic number is 1. It is placed in first group and first row. This is hydrogen. Then lithium, sodium, potassium, rubidium, cesium and francium. All these elements, these are placed in the first group. These are called as alkali metals. Now in second group, there is a beryllium, then magnesium, atomic number 12, calcium, strontium, barium and radium. These are called as alkaline earth metals. So this is the first group, this is the second group. In first group, last electron enters in s orbital, and in case of second group, again electron enters in s orbital. Here s orbital is completely filled in case of second group elements, and therefore first and second group elements, these are the s block elements. Now in third group, there is a scandium, yttrium, lanthanum. Actually, along with lanthanum, there are 14 more elements, that is atomic number 58 to atomic number 71. These are called as lanthanides. Actually, all the 15 elements, that is lanthanum plus 14 4F series elements, that is lanthanides, altogether 15 elements, these are placed at a same position, that is third group and sixth row. These are called as lanthanides, and it is very difficult to write all the 15 elements over here. Actually, periodic table is a 3-dimensional, where lanthanum is at the base, and then next element cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium and lutetium. These elements arranged one over the other, okay, and at the top there will be the lutetium. So periodic table is, it's like 3-dimensional table, and on paper it is, or on board it is very difficult or not possible to write 3-dimensional figure of this periodic table. So the remaining 14 elements, that is lanthanides, these are shown separately at the bottom of periodic table. So here is the cerium, this is cerium, it is lanthanide and 4F series elements. Then praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium and lutetium. So from atomic number 58 to 71, these are the lanthanides and they are placed in third group and sixth row. Now after lanthanum in third group there is a actinium. Okay, this is D block element again. Again in this same position, at the same position, including actinium, 14 more elements are there, like thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium and lawrencium. All these elements are placed at the same position, that is third group and seventh row. These are called as actinides. Actually actinium, it is a D block element. Now rest elements are shown at the bottom as a actinoids or 5F elements. This is the thorium, it comes after actinium. Then next is protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, then mendelevium, nobelium and lawrencium. So these are third group, these are placed in third group and seventh row, and these are actinoids. In case of these elements, 5F orbital is in the process of filling. So lanthanides, in case of lanthanides, 4F orbital is in the process of filling, and here 5F orbital is in the process of filling, and altogether these are the F block elements. Now next group is fourth group. In fourth group there is a titanium, zirconium, hafnium and rutherfordium. In fifth group there is a vanadium, then niobium, tantalum and dubnium. In sixth group there is a chromium, molybdenum, tungsten and seborgium. Then in seventh group there is a manganese, technetium, rhenium, borium. In eighth group there is a iron, ruthenium, osmium and hassium. In ninth group there is a cobalt, rhodium, iridium and meitnerium. Then in 10th group there is a nickel, palladium, platinum, then dermastadium. Then in 11th group there is a copper, silver, gold, rhongenium. In 12th group there is a zinc, cadmium, mercury and cupernicium. In 13th group there is a boron, aluminium, gallium, indium, thallium and nihonium. In 14th group there is a carbon. These are the carbon family elements: carbon, silicon, germanium, then tin, lead and flerovium. Then in 15th group there is a nitrogen, phosphorus, arsenic, antimony, bismuth and there is a moscovium. In 16th group, these are the 16th group elements. In this group there is a oxygen, sulfur, selenium, tellurium, polonium and livermorium. In 17th group there is a fluorine, chlorine, bromine, iodine, then astatine and tennessine. In 18th group there is a helium, neon, argon, then krypton, xenon, radon and there is a oganesson. So altogether there are 118 elements. Okay, 118 elements. So there are 4 blocks. These are the S block elements, group 1 and 2. Then from group number 3 to group number 12, these are the D block elements, because here d orbital is in the process of filling. therefore these are called as d block elements. Lanthanum and actinium, these are the d block elements, whereas other elements like group number 13 to group number 18, all these elements are called as p block elements, because in case of these elements p orbital is in the process of filling. And as I said, group 16 elements, that is oxygen, sulfur, selenium, tellurium, polonium and livermorium, so these are the p block elements. In case of these elements, outermost electron enter in p orbital. Okay, and fourth block is f block elements, that is cerium, this is the cerium to lutetium 4f elements, and thorium to lawrencium 5f elements or actinides, that is lanthanides and actinides, these are the f block elements. So this is about the long form of periodic table, and in this chapter we are going to discuss 16th group elements, and this is the position of 16th group elements in periodic table. Okay, now in row number 1 there are 2 elements, in second row there are 8 elements, in third row again there are 8 elements, in fourth row there are 18 elements, in 15th row again there are 18 elements, in 6th row there are 32 elements, and in 7th row again there are 32 elements. Okay, so this is the periodic table. Now occurrence of group 16 elements, and group 16 elements are oxygen, sulfur, selenium, tellurium, polonium and livermorium. Oxygen, out of these elements, oxygen is most abundant element on earth crust, and on earth crust it occur in combined state in the form of oxides. Okay, and its percentage is 47. On earth crust it exists in the form of oxides and oxysalts. Sulfur occur in native state or free state, or it also occur in the combined form as a sulfides, sulfates, etc. And most important ores of sulfur are iron pyrites, then zinc blende, that is ZnS, then calcium sulfate, bihydrate or dihydrate, it is called as gypsum, magnesium sulfate, heptahydrate, it is called as Epsom salt. So these are the important ores of sulfur. Now selenium and tellurium, these elements occur with the association of sulfur ores. So along with these ores, selenium and tellurium occur in the form of combined state, and at the time of isolation of sulfur, selenium and tellurium is also isolated in trace quantity. And here polonium, this polonium, it is the radioactive element, and there are 33 radioactive isotopes. So polonium exists in isotopic forms, and there are 33 radioactive isotopes possible for polonium. And okay, this is radioactive element, and this polonium, this is actually discovered by Curie, and it is isolated from pitch blende in the year 1898. Okay, livermorium, this is also radioactive element, and this is recently discovered. Very less chemistry is available for this livermorium. So this is about the occurrence of group 16 elements. So in next video we are going to discuss the electronic configuration of group 16 elements.